When we talk about nanotechnology, we immediately think small. But there's nothing small about the work being done by Gillian Buryak, a chemistry professor at the University of Alberta and Canada Research Chair of Nanomaterials.
So nanotechnology really is a tool for science to use to be able to build things on what's called the nanoscale. And nano comes from the Greek word dwarf, which means very small. So we actually build things on the scale of 1 to 2 to hundreds of atoms in terms of size. And then we can go and make materials that will, for instance, not fail. Aerospace materials, high performance electronic materials, semiconductor materials for faster computers, materials that can seek out individual cancer cells when that first cancer cell is formed or grows. We can make things that will recognize that and then potentially knock it out of commission. So at that length scale, it's all about the size.
But in an energy-rich province like Alberta, a province known for its oil and gas sector, Buryak is on a mission to shed some light on a different form of energy Alberta is also known for, solar energy. But exactly how far away are we from the planet becoming powered by solar energy and other renewables? It's a question that has many complex answers.
Our population is increasing. It'll reach 9 billion by 2050. And by 2050, as well as that much of the world's population, for instance, India and China, is going to is industrializing rapidly. Our energy needs are going to double, humanity's energy needs, by 2050, and triple by 2100, using the most conservative estimates. So when you think about the amount of energy that we need, the sun really provides the same amount of power hitting the surface of the earth that all of humanity needs in a year in 1 hour, one single hour. And so just the sheer quantity of energy that's there is simply so tempting. We need to be able to use that. And so right now is that with the cost of, say, silicon-based solar cells being manufactured in China, it's coming down, but still not quite there. So what we're trying to do is to make plastic solar cells. And then you could mass produce, you could print them like newspapers, plastic, flexible, very light, recyclable. And so if we could go and print them like newspapers, then we can bring the cost way down.
To help bring solar technology to the masses, Buryak and her team are dedicated to producing flexible, recyclable plastic solar cells that can be printed just like a newspaper. In fact, her team has already begun printing these sheet-like solar cells using just a basic commercial laminator. And the possible applications are endless.
You could use it anywhere. So you could imagine anything from simple funny things like cafe umbrellas that could allow you to charge electronic devices to large-scale things in developing countries, large-scale solar cells that you could simply carry on your backpack, unroll at a medical clinic, and suddenly instant power.
Down the street from Dr. Buryak's office and deep within the recesses of the U of A's Electrical and Computer Engineering Research Facility exists the cleanest research laboratory west of Sherbrooke, Quebec. It's where U of A's Nanofab director, Dr. Eric Flame, makes his home.
So inside of this room here, you have to be gowned up in the what we call a bunny suit, which just prevents any types of particles or dust from your clothing, from your skin, your hair, even your breath from contaminating the room inside. The air inside of the clean room virtually has no dust in it. In fact, if you were to measure it, it only has 10 particles of dust per cubic foot of volume of air.
Flame and his team use different fabrication techniques to imprint layers of materials onto silicon wafers, commonly used to make computer memory, microchips, and any other modern electronics found in cell phones. They then use these wafers to make specific types of small-scale sensors known as MEMS devices.
It's devices like these that allow for higher speed telecommunication applications. So your ability to watch Netflix via your cell phone connection on your phone, it's these types of devices that allow for that high rate switching of high-speed signal.
One tool at Flame's disposal is the university's brand new helium-ion microscope, which is the only microscope of its kind in Canada and only one of 50 currently available in the world. The microscope can be used as an effective tool to make things on the nano scale. By using the helium beam, researchers are able to write onto the surface of a material to the scale of 3 nanometers.
We fabricated the bridge, and then we're able to use the helium beam in order to write directly onto the bridge. That's a 10 nanometer text size, I guess you can think of it as. So while this is just illustrative of what the tool can do, what this allows you to do though is make very small devices. Using that helium beam, we've shown we can go down to 3 nanometers in being able to build very specific features. These have the ability to write down to 3 nanometers, gives you incredible opportunities in things like photonics, in things like material characterization, different application spaces that we can work on. So, as I said, it's the only microscope of its kind in Canada, so a pretty big benefit to the University of Alberta and certainly Edmonton in the Alberta.
For the Edmonton Sun, I'm Trevor Robb.